All right, guys, in today's video, we're going to be working on a cruise control problem on this old body style GMT 400 1998 Chevrolet Cheyenne pickup. It's a thermal problem, a seasonal problem. It only happens during the warm months. When it gets over 85 outside and when the engine gets warmed up, what you get is an intermittent cutout of the cruise control or failure to engage. It's an electronics problem that we don't have to look any further than this module right here on the firewall. This is the cruise control module that's mounted right here. What we think is going on inside is thermals are causing an issue with the circuit board or the soldering on the circuit board when we're driving. Now this box is discontinued by GM. You could go to the salvage yard and pull one of these boxes. There's a cable that plugs into it in addition to the harness. This cable runs all the way over this bracket into the throttle body. You can go pull this piece off, although I tell you it's probably either got this same problem or it's going to get the same problem or it has other problems. But that's one route you could go, given that the modules are discontinued by GM. But what we're going to do is we're going to pull the top of this off, this black cover, and we're going to open this up. We're not going to worry about the cable or anything. We don't need to disconnect it. We're going to pull it out, lay it on the side, take the board out and inspect the board and see if we can find anything wrong with it and then repair the circuit board itself. So let me get some tools and we'll go ahead and pull this off the firewall. Alright guys, this is held on by three number 3 Phillips head screws on rubber bushings. We're going to come in here with a number 3 Phillips socket adapter and we're going to work these off, loosen them up so we can get the harness off. We're not going to take them off until we finish that. Here and get this one. You guys are in the way. It's harder to see to line it up. All right, with those loosened up, I'm going to come in here with some silicone spray. I don't want to use penetrating oil because this could be really brittle and break, and penetrating oil could make that problem worse. So silicone should be safe for the plastic. And we won't have any problems with that. Then when we come down here to get this guy, I'm going to gently lift up on the tab, and then we're going to not grab the wiring. We're just going to grab the housing. We're just kind of wiggle him off. All right. So with that out of the way and safe, now we can go turn our attention to the rest of the fasteners, and we can go ahead and zip them off. We'll fast forward through this part. All right, we can get this guy off now. This wrench out of the way. All right, we just got to get him to kind of let go from the firewall by rocking him back and forth. Because what you're going to have is it'll get stuck. After I haven't been here for so many years. And it's these bushings on back that do that. All right, we don't need to remove anything more. We can just sit it right here and work on it. We'll be able to take the housing off right here under the hood. Now, we want to take a look for inspection. Corrosion. Actually, let me get a towel to put this guy on so he doesn't go sliding away when we start to work on him. Now we're going to be going after these T15, these small T15 screws you see in each corner. You're going to want to check for corrosion on these, but let me go get a T15 socket to take them off. Alright guys, now we got to get this top black cover off. You can see there's some T15 screws that are holding it in. They're going into this bottom aluminum or pot metal kind of housing, and what you get are dissimilar metal corrosion affecting these, and I've seen the heads shear off of these screws many times. You look at the heads and see what the corrosion situation looks like. These don't look too bad, so we might be okay. What I'm going to try to do, though, just to be safe, is we're going to come in here, we're just going to try to work a kind of a gap, very gently work kind of a gap in here so we can get some penetrating fluid sprayed in here just to be sure. Again, super steady. I'm just coming here with a little bit of PB Blaster. Just a little bit. Don't need a lot. And then we'll just keep working around the perimeter, doing each one of these that same way, right? Just enough to get a gap, and then come in here and give it a squirt. Two down, two to go. Okay, this guy over here now. Again, just a gap to get some penetrating fluid in there. So all we would need to do now, we can start the first one we did and just work it the rest of the way out. See, this guy looks nice, no corrosion on the threads, so we'll be good to be a little bit more aggressive on the others. Now, I have seen a lot of these shear off, guys. I'm telling you, it's really a thing. So, not being overly conservative here, we're just trying to make sure we don't create more problems than it's worth for this situation. This one's coming out nice and easy also. Looks good. Number 3 is good too. Number 4. This guy's coming out just fine. All right, so now we got to get this black top piece off. You know, sometimes it can just come off, so it's worth giving it a pull, but it's usually sealed up on the side. But we're just going to kind of give it a pull here to see if we get lucky, and we are not lucky. So we're going to have to break the seal here on the edge by starting in these corners. So let me get a tool to do that, and then we'll pop this guy off. All right, guys, we're just going to try lightly tapping first. We don't want to hit it too hard because we don't want to break anything. But we're just trying to see if we can jostle the sealant loose. Now, I'm not getting anywhere with that, so I'm going to try a different tool. This is just like getting a valve cover, a stuck valve cover off, right? We're going to go under here underneath. We're going to see if we can find a spot where we can work this plastic trim tool in here. We're just going to kind of tippy tap this guy. Again, we're just trying to see if we can break the seal. Trying to see which corner might work out better for us in this situation. One of these is going to let go. You just got to have patience. You know, like I said before, it's just like a valve cover. It's a matter of finding the right spot and getting it with the right amount of force to have it finally break this old weather seal here. The top housing has got some type of a gasket kind of sealant in it. And just like a valve cover after this long, it can really adhere to the aluminum piece or the pot metal piece here. So I'm just looking along the edge here, trying to see if I can find another spot to get this in here that I can get some leverage on. Maybe on this maybe on this bottom edge by the cable. Looking for a spot on the housing we can just get some leverage with the hits. But nope, I'm thinking here now, what we're going to have to do on this one is really, really kind of glued on there from age. What we're going to do with this one is going to have to kind of break this seal from the side with a different tool. So let's try a putty knife instead. I think we'll have better progress. All right, guys, just coming here with this putty knife on this same corner. There we go. This is the right tool for the job. Yep, got this side up. We can do the other corner now. Same deal. Yep. All right, so what I'm going to do is I'm going to work this tool right along this edge on both sides to break this seal right here, and we'll come back. We should have it with this tool now. All right, we got to go back and fix the audio on the other clips. Just realized the microphone was on lunch break, but we ran this guy all the way around. We didn't go in too far because we don't want to hit the board. We don't want to damage the gasket seal. But now we've got it at a point where we can take a baby pry bar like this guy, right? And we can wedge him in there. So I'm going to take a couple of these, and I'm just going to slowly, it's just like a valve cover, guys, just going to slowly work tools like this in until we can get this to let go. Now maybe it'll let go while you guys are watching, or maybe I'm going to have to, you know, keep at this and come back later. But let's see if we can get this to let go live. It's really not that bad. There we go. I hear it letting go now. All right, so just this one corner is holding on. There we go. All right, so there's a bunch of electromechanical electronics in here. Now, we don't want to get this wet. It started to drizzle rain out here. What we were after was this board. And my theory on what we've got going on, this is held in by a couple of screws here we'll have to take out. My theory of what's going on here thermally is either we've got a solder joint that needs to be resoldered, very similar to the problem that these GMT 400s used to have in the old days when they were newer with the wiper motor boards, would have to be reflowed. It's either that or we've got a hairline crack in the circuit board. Either way, when it gets hot enough, there's enough of a gap to break the circuit somewhere. So we can get this board out, we can inspect it for which is it. Is it a crack in the board, in which case we can't repair it, we're going to have to take a donor? Or is it something with the solder, in which case we can just reflow it and we can solve this problem? All right, we're going to remove these two 5mm head screws. That retain the board to the housing. And with that, we can remove the board from the housing. So now what we can do is we can start our inspection. We're going to have to get this under a microscope or a magnifying glass. What we're going to be looking for first is to see if we've got a problem with a crack in the board. And the second thing we'll do an inspection on is we'll take a look at the weld joints to this connector. I would suspect this connector more than anything else because, you know, sitting here vibrating for 26 years. It's possible it worked its way loose, but we won't know if this is an effective repair unless we can identify the problem first. So let's get this guy under a magnifying glass and I'll show you what it looks like. Okay guys, one more thing I want to say about this board before we start looking for damage. You don't have to do what I'm about to show you. If you don't have the equipment to fix this at the board level, you can just go to the salvage yard, use what I've showed you about opening up the module, pull this board out and swap it into your current cruise control module. Just take note of the part number on the side of the module and make sure that it matches the part number printed on the top of the black cover. Alright guys, if we try just to use a magnifying ring light, we really don't see anything. And I can tell the board's okay with this type of tool, but I can't really get a good enough magnification of the solder joints. So we're going to actually have to use a microscope to do that. I'm going to move this guy out of the way, and we're going to position this over here. And I'll show you what I found. Now, so here's the connector, and here's the kind of embedded microprocessor that does all the smarts on this, and the rest of these are all passive components, capacitors, resistors. There's a few ICs as well as maybe some voltage regulation going on here, a couple of transistors and diodes, but this is the main smarts on a board like this. So if we take a look at the connector and we try to focus that through on the camera side through here. Alright, if we take a look at the solder joints for the connector under the microscope, they look okay. Really not seeing any problem with these. You know, maybe this guy. But if we take a look at the solder joints for the microprocessor, now is where we can actually see something. If we get the light not as glary. You guys see the little, kind of like the circular ring around this solder joint? Right, if I come in here with a pointing device here, right there. That's a hairline crack around that solder joint. And if we take a look at several of these, we can see that that is a recurring problem. So there's our smoking gun. A lot of the solder joints are cracked on the pins of the microprocessor. So we're going to reflow the solder on all of these, and that should fix this problem. Alright guys, you can see like this kind of runny drip of a clear material. That tells us the board's got a conformal coating on it for weather protection. So we may have some extra problem heating these guys up. We're just going to flux these. I'm going to try to let you guys look through this while I look underneath it. I'm not going to show you all these pins. There's a lot of pins here. Just show you to get the idea of it. Again, we're not going to try to desolder anything. We're just going to resolder it. And again, because of that coating, we definitely want to have a fume extractor. So you can see the fumes are getting pulled off into that. I think we'll be fine just reflowing the solder that's here with the flux. I don't think that we'll have to put new solder on, but do this and then we'll take a look under the microscope again. Alright, so you guys get the idea. You want to get everything to liquefy. We use the flux because it'll help attack any oxidation that has crept into these cracks. Alright, so we're just going to go do that on all the pins of the microprocessor, and then just while we're in here, I'm going to go ahead and do it on the connector itself. So we'll come back when this is all done. All right, we've got all of this reflowed, guys. We've reflowed this microprocessor, all those pins. We went ahead and reflowed these pins on the external connector as well. And then just while I was at it, the pins that connect up to this thing here, that this kind of bridge that connects to the rest of the electronics, we went ahead and reflowed those too. Now, when we went to clean up the flux with some isopropyl alcohol, what we can see is this conformal coating is softened and liquefied by ISP. So that made it kind of a mess here and make it sticky, but there's really no way you can clean it up, and it's not going to hurt anything. It's just a cosmetic appearance, just to explain what you're seeing there. So let's go ahead and get it reassembled. All right, so she's just going to go back into these little grooves that hold the connector in place. And then we'll put these two 5mm self-tapping plastic screws. Obviously, there's no torque value for any of this stuff because you're not supposed to be in here. So we're just going to do till it's snug. It's not under any kind of stress or anything like that, just till it's snug. And now we're going to go put this back on the housing. So this groove here was kind of where the gasket was. So we're going to take a look at the condition of the gasket. We might be able to reuse it, or we might have to put some RTV in here. All right, so what we can see is that there's actually really no trace of any kind of a gasket or sealant on this guy. I think between being plugged into this bus connector and then this ridge, I think the idea was that was sufficient. But we do see evidence of some type of adhesive along the very top. So I think what we're going to do is we're going to replicate what that is. I think that's probably the best thing we could do here. So if we put this guy on, make sure we get this in the right position, like this. When we snap it in, we connect these male connectors, these female connectors, that's going to hold it in pretty tight, and then these T15s will do it the rest of the way. So I think, yeah, we'll be fine with just a very thin coating. I'm going to use this Permatex 81-158 black adhesive sealant, and I'm just going to put a very thin coat of that all around the outer perimeter. And I'm just going to use a Q-tip, right, just like this. This is what I think will most closely simulate the way it originally was, so that none of this stuff gets on anything, causes a problem, and hopefully it won't be as bad to get apart next time when we have to. So let me go ahead and do this, and then we'll come back when we're ready to snap these two together. All right, so we're just almost done with this. That's all we really need to do. And now we can put the two pieces back together again. There's no torque value on these T15s. They're another one that's just going to be snugged up. I'm just going to get a little bit that we spilt right here so that we get a snug seal. All right. All right, so she's back together. We'll put those T15s back in, and we'll snug them up. And then I'll show you a couple other things we're going to do before we remount it and give you the torque values on the Phillips. All right, so guys, I popped this cover back off real quick before we seal it up. I forgot to show you a view inside here. So in the electromechanical side, you can also have a problem, although it's unrelated to the symptoms I described. You can have a problem with these white nylon gears getting old and cracking and breaking off. This worm gear down here as well. So while you've got it open, you might as well inspect that sort of thing. Make sure you're good to go there before you continue. All right, so tightening these guys down. There's no torque value, like I said, but you don't want to crank on them too hard, right? You can see there's a gap at the bottom of the head. We just want to see that gap go away. And then two fingers, like we've got on the base of this nut driver. That's it. We don't want to have it any tighter than that. And we know we're in good shape if we don't see a gap around here. And I see a little bit of a gap there, probably because we spilt some of that sealant. Right, so I'm just going to give it a squeeze just to make sure that it's down all the way, to see if there's any other slack that we took out by doing that, and there was a slight little bit of slack. All right, so now we're done. Now we're going to take these connectors and we're going to hit it with some Deoxit G5, just again to give it the best possible shot at not having any more problems, because you only want to be in here once. Okay, now we're ready to remount this guy. We'll go ahead and plug him in. Make sure he snaps. And we'll start with this one right up on the top here. These guys are going to get torqued down to 44 inch-pounds. Get it started by hand, then we can switch to a ratchet and drive it home. But this should fix this problem, especially since we were able to confirm some problem with the solder joints. And then even though we could not visually confirm any problem with the connector joints, we went ahead and reflowed those as well, just so we don't have to come in here again. And again, it's very similar to the kind of repairs that we used to do on these GMT 400 washer windshield wiper motor boards that would also get cracks in the solder joints. All right, snug. Whoops. Let's put our hand here and save the paint. There shouldn't be anything else after this. I'll go ahead and give it for a test drive, and I'll come back and let you guys know if this solved the problem. It's supposed to be a scorcher tomorrow. I think it said 92, high of 92 or 93. So that's definitely the conditions where this would normally fail. So it was very repeatable. So if we don't get a failure tomorrow, we know this is fixed. Go ahead and torque it to 44 inch-pounds. And the reason there's a torque on this one is you've got these bushings in here and you don't want to crush them. Last one. This one we weren't really able to tighten all the way because we couldn't see it. There we go. All right, we're all ready for a test drive. We'll give it a try tomorrow. I'll let you guys know how it goes. All right, guys, we've done a couple of test drives. We just got back from a 10-mile drive here. It's a scorching, like 93 degrees today. No problems, so this was a fix. You know, the thermals around this are worth showing. I got a thermal camera here to show you, but you got the heat coming from the engine's exhaust manifold. You've got probably some heat that travels over from the throttle cable. You've got the heat where the sun's hitting the body shell coming in through the firewall. And then you've got the thing heating up itself. We've only been sitting here for maybe 5 minutes or so, and you can see how hot this guy is. Now, it's around 150 degrees. That's toasty for a piece of electronics. Even though the board's sitting up here, and this is like really hot to the touch, all the heat travels up through that bridge connector into the board. And this is late 1980s type electronics, right? So this is, you know, not something that's as heat tolerant as some others might be, where you've got a potted module where it's insulated. This is just the board sitting out there in the open. Anyway, this was the fix for this particular problem. If you did this repair, as I showed you, and I think I mentioned earlier, and it didn't correct it, then the problem's not on the board, but one of the chips. You could have a thermal defect inside one of the integrated circuits, in which case you just got to replace that whole board rather than trying to reflow it. So that's another thing you can do. But either way, all of these thermal intermittent problems are going to be that low circuit board. If you got feedback or questions about what we did today, go ahead and leave a comment below and I'll try to help. If this got your cruise control working and got your vehicle back on the road, pay it forward and hit that like button. I'd really appreciate it. And as always, thanks for watching.